Okay, so why do we need measures of spread? Well, if I want to describe my three numbers, the mean here would probably equal 6, right? I think so, but approximately 6. However, the mean here would probably be pretty close to 6 too. But you notice these values go from 5 to 7, and these values go from 1 to 11. So we want to measure of how much our data is spread out. So just so you know, the spread here, the spread for, which one would have the greater spread, do you think? The second one. So the spread for 2 would probably be greater than the spread for 1. So I'm assuming my mean there is 6. I didn't actually calculate it, but probably pretty close to 6. So we want a measure that measures the spread of the data as well as the central value of the data. Okay? The mean and median provide two different measures of the center of a distribution. When it comes to describing the median, describing data, comma, the median and the mean do not tell the whole story for these reasons that I'm telling you. For example, if you know that some data has a mean of 6.6 hours, you don't know whether all the values are between 6 and 7 or between 1 and 12. Therefore, we need a measure of the spread or variability of the data set. Okay. So let's look at the different measures of spread. The most valuable one, the one you see most used, at least the one I've seen most used in my statistics course, was this one, the standard deviation. I think I'm coming down with something and my throat is starting to bother me. Okay. One measure of spread is the range. This is not going to be good. Okay, the range is simply is equal to the highest value minus the lowest value. Okay, that's good. It's fine and dandy. So the range for this data, if you put it in order from lowest to highest, 4, 7, 9, 8, 11, you go the biggest value minus the smallest value, that equals 7. The limitation of range is that it only uses two pieces of data. I before E except after C. Is that the rule? Two pieces of data. Okay, so we're just using the max and the min, and so you're not getting a really nice picture of range. We want something that uses all the pieces of data, which standard deviation does. Okay, the deviation is the difference between an individual value and the mean. Calculate the deviation of 4 for the data in part 1. Okay, so let's first of all, in order to calculate the deviation, we need to know the mean. So you know the mean equals xi, sum of xi, all over n. And if I were to add these up, 1, 2, 3, 4, 5, if I add up the 5 numbers, I get 39 over 5, and that equals 7.8. So the deviation for the value 4 deviation is equal to 4 minus 7.8, and that equals negative 3.8. So we're talking about the number of meals she cooks. So all we can really say is the D4 is 3.8 meals below the mean. Because it's a negative value, right? 4 is 3.8 meals below the mean. Okay. Right now we are going to do variance. In all honesty, I don't know where they use variance. The only place I know where they use variance, and maybe in some higher level statistics courses they use variance someplace, but the only place I know where they use it is to calculate the standard deviation. Okay, we're going to use standard deviation as simply square root of the variance, right, when we do, okay? But in and of itself, I haven't seen it used anywhere. Okay, so what is variance? Just like for mean, there's calculations for population and there's calculations for sample. The calculations are the same except for one thing. Notice here they divide by n minus 1 and n minus 1 and n. Now I'm sure there's some very theoretical reason why for a sample they divide by n minus 1 and for a population they divide by n. But the easiest thing that I've come up with, variance is divided by n minus 1 because it has something to do with degrees of freedom. Because now this is for a sample. Sample variance is divided by n minus 1 because this gives us a better approximation of the population variance. Okay, so sample variance is divided by n minus 1 because it gives us a better approximation of the population variance. So just like for mean, this is what I will, these are the formulas I'm looking for. This is what I'm going to test for. So what are they calculating here? Notice here they're taking each value of your sample, x1, x2, x3, x4, x5, all the way, whatever number there is in your sample. They're taking each one and subtracting the mean, and then they're squaring it. Okay, so one of the most common measures of dispersion in stats is variance, which summarizes the squared deviation of each data value from the mean. It describes the relative distance between the data points and the mean of the data. Okay, so notice they square it. The deviation is squared, so negative values do not cancel out the positive values, and if that happens you're going to lose a lot of information. So the deviation is squared, so negative values do not cancel positive values. Very important. To avoid, because if the positives cancel out the negatives, we're losing information, right? To avoid losing information. Okay, notice there are two calculations. These two calculations will give you the same answer. This one is easier to calculate. This is the easier calculate because you're not using mean, right? They call this the raw score method, and you're not using the mean. Here you're using the mean, and if your mean is rounded to 10 decimal places, it's a headache. But here you need the mean, so it's just the easier calculation. Can I explain anything better? Yes.
I have two questions. So first, is squaring the sole reason, like is preserving the positivity of the difference the sole reason why it is squared?
Yes.
Then what about using absolute value and other methods? Because technically, if
It's not the sole reason. Okay, it's not the, I'll tell you why. You see, eventually when we calculate standard deviation, we're going to get the square root of this, and that ends up being S. But if you use absolute value, that's a good question. I'm not sure I can answer that.
is an absolute value a better reflection of the deviation of data from the mean? If by squaring the difference, you may either amplify that value or compress that value.
Yes. But eventually we do take the square root. So that's a very interesting question, and I don't have an answer for you right now. Okay, I don't know. Does anyone know? Has anyone heard anything on why we would not? Maybe.
And also, is the raw score method derivable from the first?
Yes, there is a way to derive this, probably on the internet. But I haven't ever derived it. I'm just letting, because you have to know summation notation. So there's some pretty fancy work there to go from here to here.
Okay.
Yeah. You get exactly the same answer. Okay. Yeah, the range only uses two data values. Here you notice we're using all the values in our data. Yeah, every deviation counts exactly. Okay, let's do some practice here. Okay, so we're going to calculate it using, I'm going to demonstrate the easier method and the one using mean and the raw score method, whatever, and we're just going to do some number crunching now, okay? So here are the values. I just wrote them out again. It's just the values we got for the number of meals Debbie cooked on her barbecue each month. Okay, so let's calculate X bar. We calculated that already. We know X bar is 7. I calculated on the previous page. Okay, so here we go. 7 minus 7.8 is negative 0.8. And here if we go 9 minus 7.8, that's 1.2. And 8 minus 7.8 is 0.2. 11 minus 7.8, 3.2. 4 minus 7 point is negative 3.8. Now just notice if we don't square it, if I were to add this up, I would actually get 0. Can you see if unless we keep the positive value of these deviations, you know, we get a 0 if we don't do that. So we lose all our measurements. So let's square it. 0.64, 1.44, 0.04, 10.24, 14.44. So the sum of our deviations squared is that. So our variance s squared is equal to sum of xi minus x bar squared all over n minus 1. And that is equal to, we calculated the sum, 26.80 all over 1, 2, 3, 4, 5. There's 5 values minus 1. And this is equal to 6.7. What do you think the units are? Meals squared, because we squared them, right? So here just notice info is lost. Okay, now let's use this raw score method. Is there anything I can explain better? Are we good? Oh, guys, just ignore the wasp. He won't touch you if you're quiet, if you sit still. Okay, now let's use the raw score method. Oh my goodness, we have another wasp in the classroom. Okay. Alrighty, raw score method. Shh. Uh-oh. Not yet. It's only this part that should be squared. Okay. So notice how this is a little bit easier because you're not dealing with 7.8. So if we were to go, we need sum of xi squared, right? So that means we have to square it and add up all the squares. And this is sum of xi all squared. So the sum of xi is equal to 39. So let's sum up the squares. Three, 3, 1. We should get the same answer as before, which we do. So now we have 3, 3, 1 minus sum of x, oh my bad, yeah, minus sum of 3, 9 squared over 5 all over 5 minus 1. And when you work that out, you get 6.7 meals squared. Yes. Yeah, because you're actually squaring all the numbers, so you have to square the units. We're calculating variance right now. When we calculate the standard deviation, we'll take the square root. Yeah. Okay, I'm just going to demonstrate population variance, the ages of members of a stats class. So we'll use the raw score method. No sense torturing ourselves if we don't have to. This is now population variance, and the symbol for population is this. The symbol for a sample is this. I should have pointed that out. Huh? Sigma, yeah. And this is capital N. All over. We do not subtract by 1. Note, do not subtract 1. Okay, so sum of xi is equal to 206. So that if I were to, can you take my word for it, but the sum of xi all squared is equal to 5878. We could go through and calculate them all, but you believe me? Okay, there's 1, 2, 3, 4, 5, 6, 7, 8 values in this particular data set. So this is 5878 minus 206 squared divided by 8 over 8, and that is 71.6875 years squared. I went through that pretty fast. Can I elaborate on anything? You don't need to know this for your tests or for your final exam. I'm only going to test you on sample stuff. So standard deviation is the one that has most meaning for me anyway. Okay. The standard deviation is simply the square root of the variance. So notice these are all the same calculations. There's your population. I'm just taking the square root of everything we did before. The units of the standard deviation are the units of the original data set. Standard deviation is an average of the deviations. Recall that the deviation is the difference between a data value and the mean. In other words, standard deviation provides an average of the differences between all the data in the sample or population from the mean. You know what I'd be interested in knowing? If we added up the deviations, the absolute value, would we get values close to this?
That is the reason why this square root and this square root to get an average of the deviation for all the things.
Yeah. But I wonder if we just used absolute value without squaring, if we get the same answer. We'll check it later.
Yes.
Yeah.
Well, actually, if you, instead of squaring it, if you just absolute value, I think just this step will be the average for all.
If we added it up and just divided by n minus 1, will we get the standard deviation? I want to see how they compare. I wonder if they're different. We might be able to answer our own question. Yeah, I don't know. All right, calculate. Okay, so for meals, S equals square root of 6.7, and that is approximately 2.6 meals. So, on average, how do we interpret standard deviation? On average, Debbie's number of meals per month What's wrong? Okay. On average, Debbie's number of meals per month is 2.6 meals from the mean. Let's do the H one. So, sigma is, because that was a population, right? That is approximately 8.5 years. On average, all ages are about 8.5 years from the mean. Can I explain anything better? This is kind of a difficult interpretation. Students usually have trouble with that. So I will ask you on the test to interpret the standard deviation you calculated. So, here I have another formula for standard deviation, and you should add it to your list here. Just this should include this formula as well on your study notes. I didn't list it up here, but this is for group data. This is for group data. You need to put that up here so you don't forget, okay? See formula page 24. Huh? This is another this is standard deviation for group data. Notice you have 1 of those, 4 of those, 12 of those, etc. So let's do this guy. When we go through and, well, the sum of our frequencies, notice now we're using frequencies here, times frequency divided by sum of our frequency minus 1. So sum of our frequencies is equal to 30. X bar is equal to the sum of xi fi over the sum of fi. And if I were to go 2 times 1 plus 3 times 4 plus 4 times 12 plus 5 times 8 plus 6 times 5, I would get 132 over 30, and that is equal to 4.4. So our mean is, sorry? Okay, you're okay? 4.4, 4.4, 4.4, 4.4, 4.4. Now we're going to go 2 minus 4.4, right? Xi. These are our deviations here. So that's going to be negative 2.4. 3 minus 4.4, negative 1.4. 4 minus 4.4, negative 0.4. 5 minus 4.4 is 0.6. This is 1.6. Square these, right, so we don't lose information. 5.76, 1.96, 0.16, 0.36, 2.56. So here we have one of those, right? So 1 times that is 5.76. 4 times that is 7.84. 12 times 0.16 is 1.92. 8 times 0.36 is 2.88. 5 times 2.56 is 12.8. So the sum of xi minus x bar squared times fi is equal to 31.2. So S equals square root sum of xi minus x bar all squared fi all over fi minus 1. Don't forget the square root comes all the way down there. This is equal to 31.2 over 29, and that is about 1.04. So if we were to interpret this standard deviation, on average, the number of potty breaks per day is 1.04 breaks from the mean. Questions like number 14 you cannot do yet. I haven't taught percentile. Let's maybe cross out some of these questions so you don't waste time on it. So this one you'll be able to do tomorrow. Don't do that today. I wouldn't worry about this. I would never test you on that.
Is it possible? 13.
These questions I'm not really interested in. And this question here, the numbers are ridiculously big, so I don't want you to worry about that one either, okay? So this is more for tomorrow. These I wouldn't worry about. But you can do the rest, okay? You can do the rest. Here, I'll put it back up so you can see it.